Okay, hello everybody. You can hear me fine now?
Yes, sir, absolutely.
Okay. Now this is a tutorial essentially. I usually give it on person-to-person basis, and usually it's interactive. That means that people can stop me at any point and ask questions. I mean, we can try it here. I don't know how it will work. Or if it doesn't work, please keep your questions and I will answer them at the end. Now, writing papers and reports is a process that requires organization of the collected information and its effective presentation. In my internet search, I found among the many sources two that are directly relevant to this workshop. The first is an article by Dr. Angel Porsche, and the second is a presentation taken from an Elsevier author workshop organized at the Honai University on the 22nd of October 2008 and delivered by Professor Joseph Hun Wei Lee from the University of Hong Kong. Now, let's start with thinking. Think about why you want to publish your work and whether your work is publishable. Writing a paper starts well in advance of the actual writing. In fact, you must think about why you want to publish your work at the beginning of your research when you question your hypothesis. You need to check then if the hypothesis and the survey experiment design are publishable. Ask yourself, have I done something new and interesting? Is there anything challenging in my work? Is my work related directly to a current hot topic? Have I provided solutions to some difficult problems? If all the answers are yes, then you can start the preparation of your manuscript. If any of the responses are no, you can probably submit your paper to a local journal or one with a lower impact factor. Now, what do we mean by impact factor? The impact factor of an academic journal is a measure reflecting the yearly average number of citations to recent articles published in that journal. It is frequently used as a proxy for the relative importance of a journal within its field. Journals with higher impact factors are often deemed to be more important than those with lower ones. The impact factor was devised by Eugene Garfield, the founder of the Institute for Scientific Information. Impact factors are calculated yearly starting from 1975 for those journals that are listed in the journal citation reports. Where do I find the impact factor of a journal that I am interested in to publish my work? Below are the hyperlinks of two websites where you can find the impact factors of most periodicals. We, the applied geochemists, publish papers in journals that are assessed by the following organizations. You must remember that the impact factors are published with a delay of at least 6 months because all papers published in the previous years have to be assessed. Nowadays, most journals publish the impact factor on their website, which makes life easier for you. Now, here we see the impact factors of some journals. And as you can see, Nature has an impact factor of 55. I don't recommend that you go there for your first paper. It's very, very difficult to get it through. Then you have Nature Communications, 17.2. Then we go to the normal journals. Science of the Total Environment, again, is difficult, it's demanding. Again, I don't recommend you go for that journal as well, and also environmental pollution. You can try environmental geochemistry and health. applied geochemistry, environmental sciences with a lower impact factor, but again, they are very demanding. Even geochemistry and exploration environment with 1.7 is very demanding. So you have to write a very good article even for these journals. Now, let us go back to the post questions. When responding to the questions, you should keep in mind that reviewers are using questionnaires in which they must respond to a question such as, does the paper contain sufficient new material? Is the topic within the scope of the journal? Is it presented concisely and well organized? Are the methods and experiments presented in a way that they can be replicated again? Are the results presented adequately? Is the discussion relevant, concise, and well documented? Are the conclusions supported by the data presented? Is the language acceptable? Are the figures and tables adequately and well designed? Is the presented information duplicated? Are they too many? Are all references cited in the text included in the reference list? So you have to decide what type of manuscript you are going to write. You have at least 3 options on the type of manuscript. Full articles or original articles are the most important papers. Often they are substantially completed pieces of research that are of significance as original research. Letters, rapid communications, short communications are usually published for the quick and early communication of significant and original advances. They are much shorter than full articles and usually strictly limited in size depending on each journal. Review papers or perspectives summarize recent developments on a specific hot topic, highlighting important points that have previously been reported and introduce no new information. Normally, they are submitted on invitation by the editor of the journal. Now, when looking at your available information, you must self-evaluate your work. This is very important. Is it sufficient for a full article, or are your results so thrilling that they should be shown as soon as possible? You should ask your supervisor, if you are a PhD student, or an experienced colleague for advice on the manuscript type to be submitted. Remember also that sometimes outsiders, that is, colleagues not involved in your research, can see things more clearly than you. Whatever type of article you write, plan to submit only one manuscript, not a series of manuscripts. Normally, editors hate this practice since they have limited space in the journals and a series of manuscripts consumes too many pages for a single topic or an author group of authors. You have to choose the target journals. A common question is how to select the right journal for your work. Do not gamble by scattering your manuscript to many journals at the same time. This is not the professionally correct procedure. Only submit once and wait for the responses of the editor and the reviewers. The most common way of selecting the right journal is to look at the articles you have consulted to prepare your manuscript. Probably most of them are concentrated in 1 or 2 journals. Read very recent publications in each candidate journal, even in press, and find out the hot topics and the types of articles accepted. Also, consider the high rejection rates of the journals. For example, Nature, Science, The Lancet, and Cell, they have over 90% rejection. And if your research is not very challenging, focus on a more humble journals with lower impact factors. You have to pay attention to journal requirements in the guide for authors. After selecting the journal for submission, go to the webpage and download the guide for authors. Print it out and read the guidelines again and again and understand them. They generally include detailed editorial guidelines, submission procedures, fees for publishing open access. This means that if you want your article to be freely downloaded, the editors the journal loses money, so you have to pay the fees for being open access, and also copyright and ethical guidelines. You must apply the guide for authors to your manuscript, even for the first draft, using the proper text layout, references, citation, nomenclature, figures, and tables, etc. Following this simple tip will save you your time and also the editor's time. You must know that all editors hate wasting time on poorly prepared manuscripts. They may well think, since the author shows no respect for his work, why should I bother with this article? Pay attention to the structure of the paper. More and more journals have new types of structure for their articles, so it is crucial to consult the guide for authors. However, in general, most of them follow the same structure. A section that enables indexing and searching for the topics, making the paper informative, attractive, and effective. It consists of the title, the authors, and their affiliations, the abstract, and the keywords. A section that includes the main text, which is usually divided into introduction, methods, results, discussion, and conclusions. A section that includes the acknowledgements, references, and supplementary materials or annexes. And the general structure of a full article follows the I am right format, introduced as a standard by the American National Standards Institute in 1979, which responds to the following questions. Introduction. What did you others do? Why did you do it? Methods. How did you do it? Results. What did you find? And discussion and conclusions. What does it all mean? And you may decide to have separate the conclusions from the discussion and have a different, completely different section for conclusions. And in this case, you have to ask yourself, are there any useful conclusions that need to be separated from the discussion? It's important to understand publication ethics to avoid violations. One of the worst things in science is plagiarism. Plagiarism and stealing work from colleagues can lead to serious consequences, both professionally and legally. Violations include data fabrication and falsification, improper use of human subjects and animals in research, and using another author's ideas or wording without proper attribution. It is also possible to commit ethic violations without intending to. Educational resources include the Publications Ethics Resources Kit. You can find it in this website, which is from the Committee on Publications Ethics. Please study them. Further, I recommend you to read the following two open access papers. This one, which is really good, and also the second. They will help you to understand what I mean. Now, closing advice of this first section. As you prepare your manuscript, there are some basic principles you should always keep in mind. Cherish your own work. If you do not take care of your work, why should the journal care? There is no secret recipe for success, just some simple rules, dedication, and hard work. Remember that editors and reviewers are all busy scientists just like you. Make things easy to save them time. Now, how to write a good paper for a top international journal. Now, this talk is taken from an Elsevier author workshop, as I said earlier, and I have modified it slightly for the purpose of this workshop. Now, the outline of the workshops: why do scientists publish? How to write a good manuscript for an international journal, preparations before starting, construction of an article, technical details, revision and response to viewers, ethical issues, conclusion and what gets your paper accepted. Let's start from what problems have been found in the submissions. Now, I use an example from China because researchers there have a serious problem with English. While they do a lot of excellent research work, but when they are submitted, there are a lot of problematic issues. According to Paul Hattert, editor of the Journal of Chromatography, the following serious issues were encountered: multiple submissions, submissions of a paper already published in Chinese, plagiarism, especially of small parts of a paper. The following problems appear much too frequently: papers which are clearly out of scope, failure to format the paper according to the guide for authors, inappropriate or no suggested reviewers, inadequate response to reviewers when the paper is reviewed, and inadequate standard of English, and resubmission of rejected manuscripts without revision. This is the worst thing. They resend the paper without doing any revision. And who have to deal with all these problems? Editors and reviewers. They are the most precious resource of a journal. They are practicing scientists, even leaders in their fields. They are all busy people doing their own research, writing and teaching, and working for journals in their spare time to contribute to science. Editors may receive a small payment, but reviewers are unpaid. Please remember this. Remember, these are scientists just like you. Make their life easy by preparing a well-structured manuscript. This workshop will tell you how. The bottom line: English, whether we like it or not, is the universal language of scientific communication nowadays. Unless a scientific or technical paper is written properly, it cannot be assessed properly. Writing a scientific paper is an intense intellectual activity. The writing process sharpens your own thinking, so it is for your benefit to write a good paper. Don't rely on AI. I will end my talk about this. The editor asks, what did I learn from reading this paper? Because usually the editor reads your paper first. And what I usually do is read the abstract and conclusions. And if I don't like them, I just return the paper to you. Is it worth knowing? Will this paper have an impact factor on the field? For example, I see journal citations. This is the Institute of Scientific Information. Citations in professional literature, for example, benchmarking technical reports and textbooks, and professional application, e.g. engineering design, software, patents, etc. So why do scientists publish? This is the first one. So your personal reasons for publishing. This may be your reasons: PhD degree, get funding, get promoted, and many other reasons. However, editors, reviewers, and the research community will not consider this reason when assessing your work. Scientists publish to share with the scientific community something that advances, not repeats, knowledge and understanding in a certain field. The following should be your reasons: to present new, original results or methods, to rationalize published results, and to present a review of the field or to summarize a particular topic. Journal publishers do not want zero-sided articles because they want to promote their journals. Editors now regularly analyze citations per article. For example, the statistics are that 20% of our papers were not cited in 5 years was disconcerting. This was the evaluation. It certainly indicates that it is important to maintain high standards when accepting papers. nothing would have been lost except the CVs of those authors would have been shorter. Remember that articles are increasingly checked on originality and relevance. Now, preparations before starting. Check the originality of your idea. Have you done something new and interesting? Is there anything challenging in your work? Is the work directly related to a current hot topic? Have you provided solutions to any difficult problems? If all the answers are yes, then start preparing your manuscript. Track the latest results regularly in your field. New and relevant articles get published all the time. Use Scopus for your search. And I use here two keywords, environmental and geochemistry. And as you can see, I found 14,264 documents. So it's impossible to sort of review all those papers. So let's learn it. I use Erpan and geochemistry and another and Lavrion, and two documents were found. So this is much easier, if I want to write something on Lavrion, I would like to sort of read these papers first. Decide the type of your manuscript. Full articles, original articles, letters, rapid communications, short communications, review papers, perspectives. Self-evaluate your work. Is it sufficient for a full article, or are your results so thrilling that they need to be shown as soon as possible? Ask your supervisor and colleagues for advice on manuscript type. Sometimes outsiders, as I said before, see things more clearly than you. Who is your audience? This is important. Do you want to reach specialists, multidisciplinary researchers, or a general audience? You will need to adjust the information and writing style accordingly. Journals, even in similar subjects, reach readers with different background. Each journal has its own style. Read other articles to see what gets accepted. Is the readership worldwide or local? Choose the right journal. Investigate all candidates to find out aims and scope, types of articles, readership, current hot topics, go through the recent abstracts. And, for example, I usually publish in the Journal of Geochemical Exploration because I know it better. You must get help from your supervisor or colleagues. Chase them if necessary. Articles in your references will likely lead you to the right journal. Do not gamble by scattering your manuscript to many journals. Only submit once. International ethics standards prohibit multiple simultaneous submissions because editors do find out. Read the guide for authors again and again. Apply the guide for authors to your manuscript, even to the first draft, the text layout, paper citation, nomenclature, figures and tables, etc. It will save your time and the editor's time. All editors hate wasting time on poorly prepared manuscripts. It is a sign of disrespect from your side. So I always say, since they do not respect me, this paper is not worth looking at. Construction of an article. Content versus presentation. Content is essential, contains a clear, useful, and exciting scientific message. Presentation is critical, conveys the author's thoughts in a logical manner such that the reader arrives at the same conclusions as the author. Constructed in the format that best showcases the author's materials. Written in a style that transmits the message clearly. A good manuscript immediately leads readers to its scientific significance. The general structure of a full article, here it is again, We have the title, author, abstract, keywords, make them easier for indexing and searching. They are informative and attractive and effective. Then we have the I am read structure. Each has a distinct function, acknowledgements, references, and supplementary material. The progression of the thematic scope of a paper. Usually we have general, particular, general. However, we often write in the following order. This is the usual way. Figures and tables first, methods, results and discussion, conclusions and introduction, and abstract and title. It doesn't really matter how you start. It's the thing is when you finish the paper to have a logical structure at the end. The title. A good title should contain the fewest possible words that adequately describe the contents of a paper. Keep your title short. Effective titles. Identify the main issue of the paper. Begin with the subject of the paper. Are accurate, unambiguous, specific, and complete. Do not contain infrequently used abbreviations, and they attract readers. You promote your work with the title, if it's attractive. So here is one of my papers. The main issue is scientific. The title honestly reflects the subject matter of the paper, as you can see in the abstract. You can download this later, or if you cannot download, please send me an email and I will send it to you. Keywords are important. And in your selection, you have to be careful not to use keywords that are in the title. This is something that we have been a mistake that we have also made ourselves. It's better not to use keywords that are already in the title, because the title essentially is used as all the words there are keywords. So you have to have additional keywords in the keyword list. Authors and affiliations. Keep your name and affiliation consistent. For example, here we see this person has two different ways of writing his name. The following names are also found in the literature. So indicate your family name and given name clearly. The names of non-English authors sometimes present great problems because editors do not know which is the first name and which is the second name or surname. So important to write your first name first and your surname or family name second. Alternative spellings lead to online confusion. Example 2, Beijing University of Aeronautics and Astronautics. And then you have Beijing University of Astronautics and Aeronautics. Beijing University of Astronautics and Aeronautics, Beijing. So this is confusing the editor. The abstract, the advertisement, this is the advertisement of your article. A good abstract is precise and honest, can stand alone, uses no technical jargon, is brief and specific, and cites no references. The quality of an abstract will strongly influence the editor's decision, and not only. The reviewer reads the abstract and decides if it is worth his time to review your paper. Keywords used for indexing. Check the guide for authors, number, label, definition, thesaurus, range, and other special requests. Avoid keywords with a broad meaning. Words selected should reflect the essential topic of the article. Do not select, for example, soil. Avoid using the words in the title as keywords, as I said previously. Only abbreviations firmly established in the field are eligible in the abstract. Now here we have made a total mess. Okay, as you can see, we have used many keywords which are, well, actually all the keywords that are already in the title. So this was completely wrong. We should have used other keywords that complement the main topic of your research, including related words and or methodology-specific terms. For example, in this case, we should have used aqua regia, the fraction less than 2 millimeters, quality control, harmonized data set, exposure, and in a sense, the article would have been better searchable. Introduction. This is important. You have to convince the readers that your work is important. Answer a series of self-questions. What is the problem? Are there any existing solutions? Which is the best? What is the main limitation? What do you hope to achieve? Provide sufficient background information to help readers evaluate your work. General background. Review articles cited, problems investigated, particularly in this piece of research. Review the main publications on which your work is based. Convince readers that your work is necessary from the introduction. Use words or phrases like however, remain unclear, etc. to address your opinions and work. Pay attention to the following. You want to present your new data, but you must put them into perspective first. Be brief. It is not a history lesson. Do not mix introduction, results, discussion, and conclusions. Keep them separate. Do not overuse expressions such as novel, first time, first ever. This is not your job. You're not trying to convince readers by saying these words. And citing relevant references is very important. Now, this is a good paper. Well, it is my paper, of course. Anyway, there are many good papers. I'm just it's a joke, but it's a good introduction to what the paper is all about. As I said, if you cannot download it, please send me an email and I will send it to you. Now, this is not to write something like this. As you can see, this person is writing and writing and writing a lot of things which are not necessary. So he was, unfortunately, because I was the reviewer, and as you can see, after he got my review, he almost had a heart attack. Methods. How did you study the problem? The basic principle, to provide sufficient information so that a knowledgeable reader can reproduce the experiment or the derivation. Empirical papers, material study, areas, descriptions, method, techniques, theories applied. Case study papers, application of existing methods, theory, or tools. Special settings in this piece of work. Methodology papers, materials and detailed procedure of a novel experimentation. Scheme, flow, and performance analysis of a new algorithm. Theory papers, principles, concepts, and models, major, framework, and deviation. As you can see, there are at least 4 different types of paper. You have to decide which paper suits the format of your paper. Examples of different types of papers. Here is a case study paper. Again, if you cannot download it, please send me an email and I will send it to you. A methodology paper, summary paper, a new research. And again, this is an example paper whereby we followed exactly the correct procedure to get it through the paper, through the editor and the reviewers. And again, I can send you this paper. Results. What have you found? The following should be included in this part. Main findings listed in association with the methods. Highlighted differences between your results and the previous publications. especially in case study papers, results of statistical analysis, results of performance analysis, especially in the methodology or algorithm papers, a set of principal equations or theorems supporting the assumptions after a long change of inferences, especially in theory papers. We always say a figure is worth 1,000 words, so they should be simple. Figures and tables are the most efficient way to present results. Your data are the driving force of the paper, therefore your illustrations are critical. The captions of figures and tables should contain sufficient information to make the figures self-explanatory. Here we see a table, okay, simple and understandable. We here clear comparative results, okay, between or among different samples. And as again, you have to be clear with all your illustrations. No illustration should duplicate the information described elsewhere in the manuscript. For example, here you have an illustration and a table. In this case, the table gives the experimental results and is more direct and clear than this illustration, which is in most cases confusing. Illustration should be only for essential data. Look at this. This long and difficult to read table can be better expressed if you study it carefully in writing this very simple sentence. The surface soil samples were dark grayish-brown, grading to light olive-brown woodland, light olive-brown wetland, and pale olive grassland at 100 centimeters depth. Okay, all the other things are unnecessary. Appearances count. Plot 3 or 4 datasets per figure. Use subplot panels to assemble figures which illustrate the same type of problem. Well-selected scales, appropriate axis label size, symbols clear to see, and datasets easy to discriminate. This is a poor figure. Again, this is a poor figure because, again, here you don't give enough information in what the samples mean. This is slightly better because you explain, as you can see, what you are plotting. Okay. Now, this is even better because you have separated the 4 datasets into 2 separate diagrams, and they give you a clear picture of what you want to display. So you have to be careful not to have a lot of information in one figure, which is difficult to read. Okay, look at it. This is much, much better. And again, I have shown you this earlier. This is very clear. You can compare between 3 different sample sets, and the comparison is very clear. Figures, problems with some papers. Figures are of poor quality, legend is not complete, scale is missing, north arrow is missing, coordinates are missing, and overall layout of map or figure is poor. An important map that most times is missing is a country map showing the location of the study area. Advice: upon drawing the figures and maps, print them at the publication scale to assess readability. If not, redraw them again until your figures and maps are legible. Now, you have to be very careful with statistics. We have here the correlation R 0.772, but please look at this very, very carefully. Okay, when you have a correlation, a linear correlation, you must always plot an XY plot to see the distribution, and you study it. And to ask your question, is the linear correlation coefficient verified by the XY plot? Now, let us look more closely at the statistics and the fitted linear model describing the relations between the X and Y elements. The equation of the fitted model is Y equals 0.004 by X and so on. What does statistical theory tell us? Since the p-value is 0.002 in the ANOVA table is less than 0.05, there is a statistically significant relationship between X element and Y element at the 95th confidence level. The R-squared statistic indicates that the linear model as fitted explains 59.6% of the variability. That is 59.6% of the data is explained by the linear model and the remaining 40.4% by some other relationship. The correlation coefficient equals 0.772, indicating a moderately strong relationship between the variables. Questions. Do the above statistics agree with the XY scatter plot? Not really. We have a poor linear correlation as depicted by the scatter plot. So what happens here? The actual statistics are wrong. And we'll find out why in a minute. Classical statistics such as Pearson's linear correlation coefficient require that the data must come from a single population and follow a normal Gaussian distribution. Let us now examine our data set very carefully, especially its statistical distribution. I recommend that you use box and whisker plots. I will not go through this. You can study at your leisure, and also you can study the paper. They are very good because they display the statistics of your data set. Here we see the box and whisker plot together with the normal distribution curve. How they are compare. That you must remember again that classical statistics demand that the data must be univariate and follow the normal or Gaussian distribution. Okay, we have different types of Gaussian distributions. And you can use the cumulative distribution function to find out if they are Platin-Kirchner, Lepto-Kirchner, or normal. What do we know about the statistical distribution of geochemical data? Question 1. Are our geochemical results normally distributed? Do our geochemical results come from a single normal population? How do we study the statistical distribution of our geochemical data set? We plot histograms. Here, I ask you first, how many populations can you distinguish? Well, you normally ask you, but I will tell you here, we can see two distributions at least. It is better to use the cumulative frequency curve because it shows much better the statistical distribution of geochemical results, as you can see in this paper. Now, the question is, how many populations can you distinguish for element X? Here we are. We draw straight lines between each for each section, and as you can see, we can see that there are 6 populations in this distribution. Now, how many populations can you distinguish for element Y? Again, you have to sort of draw straight lines on this cumulative frequency curve. And here they are. Here we see at least 5 log normal populations. Because, I forgot to say that, because we use a log probability paper, in order to sort of see the situation better, because the geochemical data follow log normal distributions. So what is then our conclusion about the statistical distribution of the concentrations of element X and Y? As our data do not come from a single normal distribution, we cannot use Pearson's linear correlation coefficient. Similarly, we should not use the mean or standard deviation. Hence, nowadays, in almost all the applied geochemical papers, we use the median and median absolute deviation method. Now, tables. Be careful when you compile tables. Now, the top one, as you can see, is crowded, and when revised, it's much better, and you can read it much, much more clearly. Important. When you compile tables, you must follow the following format. For results from 0.100 to 0.999, you only use 3 decimal values, 0.123. Now, from 1 to 0.999, you use 2 decimal values, 1.23. From results from 10 to 99.9, you use only 1 decimal value, 12.3. And for values above 100, you only use integers, 123. Use color only when necessary. Here is a very poor result using color. We cannot see anything really, or it's difficult to see. Again, I'm stressing the crowded table. The same filter conditions are repeated 4 times. So this is an awful table. Now, a few statistical rules for the results section. Indicate the statistical test used with all relevant parameters. Median and interpercentile range, 7 years. Mean and standard deviation to report normally distributed data. Remember, only if your data come from a single normal population. Median and interpercentile range to report skewed data. That numbers usually reported in the form of 2 significant digits unless more precision is necessary, as we can see here. In the compilation of statistical tables of our geochemical data set, we use the median and median absolute deviation. Of course, we use the minimum and maximum values. And if we want to provide additional statistical information, we use the percentiles, for example, at 10, 25, 75, 90, and 95%. To prove my point about the use of the median instead of the mean value, the following results are presented in the next few slides. This is an area that we have carried out a stream sediment geochemical survey in the northeastern part of Greece, in Iron River, as you can see the little map. And the mean, as I said, the mean versus median we're studying now. The stream sediment geochemical survey of the Iron River catchment basin comprises 862 samples. The contamination train from the same Philippe mine and ore beneficiation plant is clearly shown in the main stream. You can see the dots that are our larger size. Now, the bottom where shows the different layers of overbank sediment. These are the floodplains at different times. You can see the contaminated overbank sediments at the top, and the pristine conditions as you go to lower levels. Now, what I have done, I have removed the 30 samples with lead values from 500 to 11,200 milligrams per kilograms from the database, and the map was replotted, and as you can see, we have some areas that are showing anomalies that were not shown before. Okay. Now, what is the interesting point is that the mean value is affected by the extreme values, whereas the median, we say, is more robust because it is not affected by such extreme values. Lead has a mean value of 157 milligrams per kilogram when all 162 sample values are considered, and the range of values varies from 5 to 11,200 milligrams. Now, when the extreme values are removed, the values in the remaining 832 samples vary from 5 to 570 ppm lead with a mean value of 32.7. So as you can see, the difference between the two mean values is quite large. 157 ppm with all samples and 32.7 ppm lead when the contaminated samples are removed. It's quite a large difference. However, the median value in both cases is at 20 milligrams per kilogram lead. So the conclusion is that the median is not affected by extreme values on either side of the scale. As you can see, okay, sorry, I already said that. So we say the median is robust, more appropriate, and more relevant for geochemical data, whereas the mean is affected by extreme values at both ends of the scale and also is not appropriate because this particular dataset does not come from a single normal population. Discussion. What do the results mean? Check for the following. How do your results relate to the original question or objectives outlined in the introduction section? Can you reach your conclusion smoothly after your discussion? Do you provide the interpretation for each of your results represented? Are your results consistent with what other investigators have reported, or are there any differences, and why? Are there any limitations? Do not make statements that go beyond what the results can support and suddenly introduce new terms or ideas. Unfortunately, this happens with many papers. Watch out with known quantitative words. For example, low, high, extremely, enormous, rapidly, dramatic, massive, considerably, exceedingly, major, minor. They are often qualified by very, quite, slightly. Quantitative description is always preferred, but note subtitles. The effect of adding N was minor, is not quantitative. The effect of adding P was to increase dry weight by 60%, whereas the effect of adding N was minor, is given a sense of a quantitative definition. What does P really mean? Again, a quantitative qualification is needed. Ask for help. Ask your colleagues to read results in discussion before you go further. Check the organization, number and quality of illustrations, the logic and the justifications. Revision of results and discussion is not just paperwork. You may do further experiments, derivations, or simulations. Conclusion. How does your work advances the field from the present state of knowledge? A clear conclusion section helps reviewers easily judge your work. To present global and specific conclusions in relation to objectives. Indicate uses, extensions, and limitations if appropriate. Suggest future experiments and point out those that are underway. Do not summarize the paper. The abstract is for that purpose, not in the conclusions. Make a list of trivial statements of your results. This is often done and is not correct. Make judgments about impact, another problem. Use uncertain words such as might, probably, possibly. So see that the paper is very good. Now, again, this is a good paper, and I can send it to you so you can read the conclusions at your leisure. Acknowledgements. These are very important because it's your chance to thank people that will help you, for example, technical help, English revision, funding organizations, affiliations to projects and programs, and reviewers and editors, especially in the revised manuscript. Do ask permission from those who help you, who will be acknowledged with their names mentioned. Sometimes people do not like to be cited, and so you have to ask for their permission to write their names in the acknowledgements. State clearly why they are acknowledged. Include the grant number or project reference. And again, this is a very clear way of acknowledging people. References. Get them right the first time. Please conform everything to the guide for authors of the journal. It is your responsibility, not of the editor and the reviewers, to format references correctly. Check the spelling of author names and the year of publication. This is what I hate when I see references with, first of all, the title is wrong, the names are wrong, and this is really awful. And immediately I stop the review and return it to the author. Punctuation use of étal and others. Be careful when you use it. You don't use it, sorry, in the references. Avoid, because sometimes there are more than 10 authors. There is a reason for why there are more than 10 authors. Each one has contributed, especially if it's a very large project. So all author names should be cited. Avoid citing the following if possible. Personal communications, because the editor and the reviewers cannot check this. Unpublished observations, again, we cannot check this. Manuscripts are noted but not yet accepted for publication. Again, this cannot be checked. So please avoid referencing these sort of items. Articles published only in the local language. Again, this is something done in China, and this is something that we cannot check, and also in some other countries. So we cannot find even the publications. So please do not use the citations for publications published in your own languages. Avoid excessive self-citation and journal self-citation. This is important. This is not very nice, and it doesn't look very good on you as well. For example, here there are self-citations, and this particular journal was self-citing itself and is no longer in the ISA list. Supplementary materials. These are very important. Supplementaries are of secondary importance to the main scientific thrust of an article. However, it is important to provide all the data sets you use so that interested readers can repeat your experiments. And this adds value also to your paper. Not a part of the main article will be available online to readers if the paper is eventually published. All the information should be related and supportive of your article. Now, some technical details. Suggested text layout. Okay, you have to set up your Word file correctly. I kept the old Microsoft Word command screens because, unfortunately, In some regions, they do not have the recent Word articles. Keep it consistent throughout the manuscript. Double line spacing at 12-point times New Roman font is preferred. Make it convenient for reviewers to make annotations. Number the pages, number the lines if the journal requires you to do so. Suggest the length of the full article. 25 to 30 A4 size pages is the ideal length for a submitted manuscript, including essential data, according to Julian Isho. And this is the setup: title page, abstract, 1 paragraph, introduction, 1.5 to 2 manuscript pages, methods, 2 to 4 manuscript pages, results and discussion, 10 to 12 manuscript pages, conclusions, 1 to 2 manuscript pages, figures, 6 to 8 is the normal situation, but it depends on your paper, tables, 1 to 3, and references to 20 to 50 usually. Letters or short communications have a stricter limitation on the length, for example, 3,000 words with no more than 5 illustrations. Abbreviations. Abbreviations should be defined on the first use in both abstract and the main text. Some journals even forbid the usage of abbreviations in the abstract. Abbreviations that are firmly established in the field do not need to be defined, for example, GIS, CFD, AAS, ICP-AS, ICP-MS. Never define an abbreviation which is never used later in the text. It's a waste of time. Acronyms. Abbreviations that consist of the initial letters of a series of words, do not overuse them. And cover letter. You have to, in your cover letter to the editor, you have basic information should be included as follows: editor names, originality of submission, no competing financial interests, suggest reviewers, and mention significance of special points. It's very short. You don't need to write a very long letter because the editor would not like it. Revision and response to reviewers. This is very important part. Why is the revision important and necessary? Which procedure do you prefer? Send out a sloppily prepared manuscript, get rejected after 4 to 6 months, send out again only a few days later and get it rejected again, and you sink into despair. Take 3-4 months to prepare the manuscript. Get the first decision after 4 months, revise carefully within the time limitation, and you get your article accepted. The key is write and rewrite until you are satisfied. Please cherish your own achievements. Now, what happens when you send your article? As you can see here, there is a flow diagram. On the right, we have the author, the managing editor, the editor, the reviewer. Okay, you submit your paper, the managing editor assigns it to the editor. He reads it. If he doesn't like it, he discusses it with the managing editor, and you get a rejection immediately. Okay. Now, if they like it, they invite reviewers, and the review, they give the recommendation, they collect the reviewer recommendations, they have to make a decision. Sometimes there is a conflict between the reviewers, and if the one says accept or reject, and the other says revision, and so on, the editor has to decide, or he has to send it to another reviewer. Anyway, in any case, a decision has to be made, and it's either accepted or rejected. And if a revision is required, they tell you to revise the paper. Remember, no one gets it right the first time. Our first paper, in all cases, was usually rejected. Write and rewrite. A good article is one that has been rewritten at least 10 times, according to 2 good friends of mine, Arthur Smith and Ashlyn Arma Brown, two very experienced colleagues. This advice was given to me during the typewriter days. So can you imagine to rewrite this article and type it 10 times? Well, we used to. Suggestions. After writing the first version, take several days of rest. Refresh your brain with different things. Come back to the manuscript with critical eyes. In the meantime, ask your colleagues and supervisors to review your manuscript first. Ask them to be highly critical and be open to their suggestions. Revision before submission checklist. Reasons for early rejection, content and aims and scope. Paper is of limited interest or covers local issues only. Sample type, geography, specific product. Paper is a routine application of well-known methods. Paper presents an incremental advance or is limited in scope. Novelty and significance are not immediately evident or sufficiently well justified. Reasons for early rejection, preparation. Failure to meet submission requirements, incomplete coverage of literature, unacceptable, poor English. And here we have the editor's comments. Okay, you can read at your leisure. And again, we have the revision goes again through the same sort of procedure. So as you know now the procedure, take care to revise your paper correctly. Okay, and then you have to also write a letter explaining all the corrections you have made according to the reviewer's comments. You have to take revision very seriously. Nearly every article requires revision. Bear in mind that editors and reviewers mean to help you improve your article. Do not take offense. Minor revision does not guarantee acceptance after revision. Do not count on acceptance before you carefully study the comments of the reviewers. Revise the whole manuscript, not just the part of the reviewers points out. This is a good time that you revise, and you tell them that not only you have revised the points that they have located themselves, you tell them that you have revised that part and so on. Okay. So as I said, the revision is a great learning opportunity. You cherish the chance of discussing your work directly with other scientists in your community. Please prepare a detailed letter of response. Cut and paste each comment by the reviewer. Answer it directly below. Do not miss any point. State specifically what changes, if any, you have made to the manuscript. Identify the page and line number. A typical problem, discussion is provided, but it's not clear what changes have been made. Provide a scientific response to the comment you accept, or a convincing and solid and polite rebuttal to the point you think the reviewer is wrong. I have done this many times, okay? But you have to be convincing and also polite, okay? Don't make angry the reviewer and the editor. Write in a way that your responses can be given to the reviewer. A sample response. Say, concerning your comment about the use term factor, you are absolutely right that the PCA, not a factor analysis, was calculated. Consequently, the term principal component should be used. The word factor was exchanged in the whole resubmitted manuscript and in the tables and figures. You suggested to use Fennoscandian instead of Scandinavia. I have accepted your suggestion and changed it in the resubmitted manuscript accordingly. The term Scandinavia is used for a historical cultural region in Northern Europe and always includes the mainlands of the three kingdoms of Denmark, Norway, and Sweden. The term Fennoscandia is the geographical peninsula of the Nordic region, comprising the Scandinavian Peninsula, Finland, Karelia, and the Kola Peninsula. And on page 5, you say how the overall precision and total variance were calculated. This description for the calculation of overall precision and total variance was added in the resubmitted text. the information about percentage of cadmium determinants below the text is also given. So you are very clear in your response to the reviewer comments. Assistance with English writing. This is indeed a problem with all non-English speaking scientists. But to be honest, I was very happy listening to all the students in this webinar. They have a very good command of English. And as I reviewed the abstracts, some of the abstracts, I was very pleased to see a very high standard of written English as well. How can this problem be overcome? Unfortunately, there are no easy solutions. Each scientist who would like to publish his her work in an international journal must learn English. Depending on a translator is a handicap because translators do not know the geoscientific vocabulary unless they have been trained. You can, of course, get help from the journals because each journal has its own such service for which you have to pay. You are again handicapped. The last part of this workshop will tackle this problem and some advice will be given to you. Rejection, not the end of the world. Everyone has paper rejections. Do not take it personally. Try to understand why the paper was rejected. Note that you have received the benefit of the editors and reviewers' time. Take their advice seriously. Reevaluate your work and decide whether it is appropriate to submit the paper elsewhere. If so, begin as if you are going to write a new article. Read the guide for authors of the new journal again and again. Don't resubmit a rejected manuscript to another journal without significant revision. It won't work. The original reviewers often find out, leading to animosity towards the author. You will be pointed out. Okay. A suggested strategy, if in your cover letter declare that the paper was rejected and name the journal. Include the referee's reports and a detailed letter of response showing how each comment has been addressed. Explain why you are resubmitting the paper to another journal. For example, this journal is more appropriate. The manuscript has been improved as a result of its previous review, etc. Ethical issues. This is an important issue. Deadly sins. Unethical behavior can earn rejection and even a ban from publishing in the journal. Multiple submissions, redundant publications, plagiarism, data fabrication and falsification. Unfortunately, I have seen this in papers. Improper use of human subjects and animals in research. Improper author contribution. Multiple submissions. This is a problem. Multiple save your time, but waste time, editor's time. The editorial process of your manuscript will be completely stopped if the duplicated submissions are discovered. It is considered to be unethical. We have thrown out a paper when an author was caught doing this. I believe that the other journal did the same. This is according to James Howard. Competing journals constantly exchange information on suspicious papers, even between competitors. They do this. You should not send your manuscript to a second journal until you receive the final decision of the first journal. Okay, don't be anxious to publish your paper because if you do this, then probably you will never publish anywhere. Redundant publication. An author should not submit for consideration in another journal a previously published paper. This is completely wrong and unethical. Published studies do not need to be repeated unless further confirmation is required. Previous publication of an abstract during the proceedings of conference does not preclude subsequent submission for publication, but full disclosure should be made at the time of submission. Republication of a paper in another language is acceptable provided that there is a full and prominent disclosure of its original source at the time of submission. At the time of submission, authors should disclose details of related papers, even if in a different language, and similar papers in press. Acceptable secondary publication. Certain types of articles, such as guidelines produced by governmental agencies and professional organizations, may need to reach the widest possible audience. In such instances, editors sometimes choose deliberately to publish material that is also being published in other journals, with the agreement of the authors and the editors of those other journals. So you have to have an agreement. Plagiarism. This is the awful part. Plagiarism is the appropriation of another person's ideas, processes, results, or words without giving appropriate credit, including those obtained through confidential review of others' research proposals and manuscripts. Presenting the data or interpretations of others without crediting them, and thereby gaining for yourself the rewards earned by others, is theft, and it eliminates the motivation of working scientists to generate new data and interpretations. For more information on plagiarism and self-plagiarism, please consult this website. Plagiarism, attempting shortcut with long-term consequences for yourselves if you do this. Plagiarism is considered a serious offense by your institute, by journal editors, and by this community, the scientific community as a whole. Plagiarism may result in academic charges, including dismissal, and will certainly cause rejection of your paper. Plagiarism will damage your reputation in the scientific community and may even ruin your career. Here you can check plagiarism checkers for your paper. I hope that you don't need it. Example of a plagiarism is this was in a paper, Chinese paper, published in it. International authorities take strong measures against scientific dishonesty. Plagiarism and stealing work from authorities can lead to serious consequences. And here we have the paper that was published by Jung Yong-son, a professor at Wang University Law School. And of course, as you can appreciate, his name was made public. Examples of ethical misconduct. A postdoctoral fellow changed the numbers in answers in order to improve the data. A colleague duplicated the results between 3 different papers, but differently labeled data in each paper. A co-investigator on a large interdisciplinary grant application reported data that a postdoctoral fellow in his laboratory falsified data submitted as preliminary data in the grant. And here is what happens if you manage to do all these bad things. This article was retracted and is on the website and will remain there because and it won't be removed from Science Direct. Everybody who downloads it will see the reason of its retraction. Okay, so these authors, now they are known that they have a retracted paper, and no journal will accept any papers from these people from now on. And here is the retracting, matching pursuit, pace, and so on. Inappropriate paraphrasing. Paraphrasing is restating somebody else's idea while not copying me verbatim. Unacceptable paraphrasing includes any of the following: using phrases from the original source without enclosing them in quotation marks, emulating sentence structure even when using different wording, emulating paragraph organization even when using different wording or sentence structure. Unacceptable paraphrasing, even with correct citation, is considered plagiarism. It's better to put the phrase in inverted commas and write the name of the author and the page number from where you got it from. Here we have an example of a word-for-word copying. So you see the original, and this paper just changed slightly the sentence, and he essentially should not have done so because he mentions the author. Okay, and when you mention the author, just write the sentence in the way he has written it, firstly in inverted commas, and also write the page number as well. Data fabrication and falsification. Fabrication is making up data or results and recording or reporting them. Unfortunately, I know somebody that has done so. Falsification is manipulating research materials, equipment, processes, or changing, omitting data or results such that the research is not accurately represented in the research record. The most dangerous of all falsehoods is a slightly distorted truth. Please remember this. This was written way back in the 18th century by Lichtenberg. Improper author contribution. Authorship credit should be based on substantial contributions to conception and design, or acquisition of data, or analysis and interpretation of data. Drafting the article or revising it critically for important intellectual content, and final approval of the version to be published. Authors should meet conditions 1, 2, and 3. Those who have participated in certain substantial aspects of the research project should be acknowledged or listed as contributors. Acquisition of funding, collection of data, or general supporting of the research group alone does not justify authorship. Each author should have sufficiently participated in the work to take public responsibilities for appropriate portions of the content. The corresponding author should ensure that all appropriate co-authors and no inappropriate co-authors are included in the paper. If there is plagiarism or other ethical problems, the corresponding author cannot hide behind or remain innocent because it is his responsibility, unfortunately. Conclusion: what gets you accepted? The author should ask, what is it that the reader will learn from this article that she did not or could not have known before? What is that knowledge important? Why is it not knowledge important? If published, will this paper be cited in the future? And assistance with English language writing. What is the solution? Well, the only practical solution is that you will have to start learning English by practicing every day. To begin with, you must think and write in English. Learn the structure of the English language by reading good English literature books and listening to BBC plays. Also, watch English-speaking child films. They are very good. You should also get a good English grammar book and an English dictionary. When you find a word you do not know, you look it up first in the English dictionary and try to understand the meaning. You only use the English country dictionary as a last resort. Every day, try to write a paragraph by thinking in English. So, what is the solution? You must think and write in English. It is certainly not an easy process, but it's the only way to master a foreign language. You also must understand that the United Kingdom English is slightly different from American English. So when you write a paper, you must write it either in United Kingdom English or American English. I will give you a vocabulary we have built since 2008 during the editing of the EuroGeosurvey's Urban Geochemistry textbook. This list is continuously being updated and which you can download, okay, from this pCloud hyperlink. Which English version are you going to use for your paper? This is a question you must ask yourself. I personally prefer the original English, which is United Kingdom English, and it is the language used in the European Commission documents. However, you are free to use for writing the manuscript of your paper either in United Kingdom or American English. Journals nowadays accept both versions. Yes, it is your choice. Upon deciding which language you will use, you must set up the language in your Microsoft Word accordingly. And this is how you do it. Okay, probably from what I've seen of all of you, you are much better than me. Now, something that is good to have is the Glossary of Geology. I have the hard copy version, but you can subscribe with only $20, and you have the online. This is a yearly fee. So while reviewing a Chinese paper, I found the term geotectogeny, which I never met before. So I searched the glossary, the online one, and I found that it does exist. Okay. But I usually search for unknown terms in either the printed version or, in this case, the printed version gives more information. The term does exist, and it originates from the Spanish term geotectogeno. Lola, you can pronounce it better than me. And as you can see, it gives you more information. Now, two terms that you have to be very careful: pollution and contamination. The Chemist Law Dictionary defines pollution as the discharge of a toxic or contaminating substance that is likely to have an adverse effect on the natural environment or life. The European Union Water Framework Directive at paragraph 2, section 333 defines pollution as the direct or indirect introduction as a result of human activity of substances or heat into the water or land which may be harmful to human health or the quality of aquatic ecosystems or terrestrial ecosystems directly depending on aquatic ecosystems, which result in damage to material property or which impair or interfere with amenities and other legitimate uses of the environment. So, contamination is the presence of an unwanted constituent, contaminant, or impurity in a material, physical body, natural environment, workplace. Therefore, contamination refers to any unwanted constituent, but with no verifiable harmful effects. While pollution refers again to an unwanted substance, but this time its harmful effects have been verified. And hence it is included in the legal terminology as well. Avoid using the term heavy metals, something that I have seen in many many presentations. Although you find that it has been used very extensively in the past. It is an ill-defined term and includes, apart from metals and metalloids, such as arsenic, beryllium, antimony, selenium. Hence, as far back as 2002, Dufus and later Chapman suggested that we should stop using this term in the scientific literature. Use instead potentially hazardous elements or potentially toxic elements. Now, artificial intelligence. You may be interested in reading something about the early artificial intelligence projects of the Massachusetts Institute of Technology that go back to the 1950s. I think if I remember correctly. Here is the web link, and you can read yourself there. What is artificial intelligence? According to John McCarthy, the man that coined the term artificial intelligence, is the science and engineering of making intelligent machines, especially intelligent computer programs, where intelligence is the computational part of the ability to achieve goals in the world. An intelligent machine can be a machine that mimics the way humans think, feel, move, and make decisions. It could also act in conjunction with a human to complement and improve their ability to do those things. There are many possible approaches to the challenge, and the definition has never had a static solution. In my opinion, do not use artificial intelligence to write your paper. Writing is a brainstorming exercise, and your comprehension improves with practice. The creative of the human brain cannot be matched by AI. Of course, AI excels in computation, speech, and accuracy in data-driven tasks, hence the reason we use computers. Just for fun, I use in Google brain activity with minus AI. Okay, when you write after your search words, keywords minus AI, the Google gives you things that are in the web. And this is what I got. Okay. Now, when I use brain activity without the minus AI, I got this information. Okay. Well, what I liked is this. The picture. It's very nice. So our wonderful brain, you can see it here in color. Use it for your work. Thank you for your attention. Here are the references, the examples of the different papers, writing scientific papers, also by Michael Watts. You can see it in the SEC website. Thank you very much.